All right, let's graph some transformations from parent functions, everybody. So number one here, we have a parent function. I've already graphed all the parent functions using this table here, so you can take a look at that. But we're going to translate these points or move those points based on these numbers up here. I've already listed the domain and range for all the parent functions as well, which is something we've already covered. So what I'm going to do here, this number right here makes it go, the graph's going to shift right to, and down 1 from that number right there. So I'm going to take all these blue points over here, and every single one's just going to move to the right 2. So if you want, you could even do it, well, it's kind of nice to do it on the same grid sometimes, but I'm going to take this point and go right 2 and down 1, so it moves it right there. So this point came here. I'm going to do that with all my points. So I'm going to go right 2, down 1 here. There was a point that started right here, so that's going to go right 2, down 1. This point ends up here when you move it right 2, down 1. And this point go right 2. 1, 2, down 1, and then we're going to have another point right here, which is right 2, down 1. So if we take this and kind of move them over here, maybe you can see how each point now went right 2, down 1. So you can see that, hopefully. That's why it's nice to put it on the same grid. So right 2, down 1 is right there. And then we just draw a nice smooth curve through those points. There you go. So that's that one. Okay, y equals 2x squared is a vertical stretch. So vertical stretch by a factor of 2. And what this does is double all of our y values. So if we go back to here, instead of these y values, we're going to double them all. So we're going to get 8, 2, 0, 2, 8. So I'm going to plot all those points on here. So we were up at 8, which is actually off the grid a little bit, but that's right. This was at 2, 2, and then we had another 8 up here. Move this out of the way. Put it there, all right. And now we can draw a graph through these points. And sometimes it's kind of hard to tell, but if I put this on the same grid as the parent function, you'll see that it actually is kind of the same graph, just skinnier. See that? So there you go. And then finally, this number here, a negative, is going to flip it upside down. It's really like having a -1 there. So the parent function gets flipped upside down, or all of the y values become negative. So it's all the same x values, but the negative y values. So 0 stays 0, but then we're going to be at -1 here, and -4 here and here. Oops, got to go over one more. Right there. And so now you can draw your parabola, which is the name of this U shape. It's called a parabola, through there. Okay, domain. It doesn't change for this. It's -infinity to infinity for all of them. Oops. Copy, paste. All right, so our domain is the same for all of them. Our range does change, though, because now this graph went lower than the first graph, because remember we shifted it down. So our range starts at -1 and goes up forever. So our range now is -1 to infinity. This one still starts at 0, so this range is still 0 to infinity. And now this range is kind of the opposite. It goes down forever, but stops at 0. So that's -infinity up until 0. Okay, so there's some quadratic graphs of transformations. Now let's look at the square root function. Remember our table here, we choose numbers that we know how to find the square root of, and you have to choose positive numbers for x or 0. You can't square root negative numbers. That's why there's no graph over here. No x values that are equal to 0. That's why our domain is 0 to infinity. Our range is also 0 to infinity. Okay, so again, I'm going to take the points that are on the given graph, and this is going to go to the left one and down 2. Make that F nicer. So left 1, down 2. So I'm going to take the point 0, 0. I'm going to go left 1, down 1, 2, and end up right here. I'm going to take this point and move it left 1, down 2, so it goes right there. And then this point, left 1, down 2, so it's right there. Okay? And then, so this graph looks like this. Literally the exact same shape, just in a different spot. So move this over to the appropriate grid here, so it looks like that. But it's nice to compare it to the parent function so you can see how it actually changed. Let's make this different than the color of the points so you can see them easily. All right, let's go ahead and do domain and range right now. So our domain, well, it moved left 1, so now we're at -1, and then it goes right forever. So our domain is -1 to infinity. Our range, we went down 2. So we start at -2, and the graph will go up forever. So that's -2 to infinity. Make that bracket look nicer. All right, then again, with our parent function, we have a negative in front, and that's just going to make all of our y values negative, except 0, because there's no such thing as -0. And so now we have 0, 0, 1, -1, and 4, -2. 1, 2, 3, 4, 1, 2. So it looks like that. So it's just an upside down version of the graph. Try to make it as nice as possible. All right, so there we go. And now our domain is still 0 to infinity. That didn't change. But now since the graph is upside down, our range actually goes down forever, like this graph continues in a downward motion, and only goes up to 0. So that's -infinity to 0 for the range of that one. Okay, x cubed. Now the nice thing about x cubed is the domain and range is the same for all of them. It's -infinity to infinity no matter what we do, because the graph goes down forever, goes up forever, goes left forever, and right forever, even though it moves side to side slowly. Like this is almost going straight up, but it's still going to continue moving to the right as we go up. All right. For this particular graph here, this is going to go right 1, and that's it. That's our only transformation here. So we take our points from the parent function and we move them right 1. So this one's going to be here, like this guy is going to be moved over 1. That one's moved over 1. This is moved over 1, moved over 1, and moved over 1. So it's going to look like the exact same graph, just moved to the right 1. Like that. Okay. Easy enough, hopefully. So that's going to be right there when I put it on the same grid, or its own grid. Okay, now this 1/2, that cuts all of our y values in half. So now we have to, we're going to be at -2, -4. So -2, -4, -1, -1/2. Half of 0 is still 0, and then this will be 1/2, and that will be 4. So we have -2, -4. 1, 2, 1, 2, 3, 4. -1, -1/2. 0, 0. 1, 1/2, and 2, 1, 2, 3, 4. Like so. And so now this graph will look something like this. Again, it's kind of hard to tell the difference between it and the parent function, but if I move this over, oops, the parent function is way over there. Hold on a second. There we go. So you can kind of see how it's skinnier. See how it's actually like below it? So that's what we're going for there. And then this last one, Sorry about this, I couldn't get rid of it, but it's just negative x cubed. And that just flips it upside down. So this one upside down, or you make all your negatives become positive and all your positives become negative is what happens to those values. So now we're at -2, +8, which goes off the grid a little bit. -1, +1, 0, 0. Then we'll have -1 and -8. So this graph goes like that. Okay. And then finally, absolute value. Absolute value is very similar to quadratics, actually, x squared. It's just a V shape instead of a U shape, but domain and range kind of have the same effect, stuff like that. So this flips it upside down, or changes all of these to negative values instead. So now we're at 0, 0, 1, -1, 2, -2, and then we have this point and this point. So I'm just taking all these points and putting them on the other side of the x-axis. So like this point moved here, this point moved here is another way to think about it. All right, and then draw our graph here. Let's use yellow. Can you see that? Whoa. All right, so that goes like that and like this. All right, making sure I did domain and range for everything. So now our domain is still -infinity to infinity. All these V shapes are going to go left and right forever. That never changes no matter what we do to it. So we have that. And now this graph goes down forever and then only goes up to 0. So that's a range of -infinity to 0. Remember, never put a bracket on infinity or -infinity because those are concepts, not numbers, so you can't actually equal -infinity. All right, this graph here, hopefully you're catching on at this point. This is going to move it left 3, down 1. So I'm taking all these points and going left 3, down 1. So I go left 3, 1, 2, 3, down 1. That was at 0, 0, and now it's there. And then we're going to have a point here, left 3, down 1, left 3, down 1, left 3, down 1, left 3, down 1 from those other points. And I'll put this back on the parent function graph and you'll see how everything is left 3 and down 1. So if I take this and move it here, left 3, so those should look pretty much exactly the same. 1, 2, 3, down 1. So that's what it looks like. So they're the same graph, just moved over and down. And then finally we have another vertical stretch. Oh, sorry, let's do the range down here. Since we moved down 1, we now have a range starting at -1, and then it goes up forever, so to infinity. And finally we have a vertical stretch of 2, which means all these y values just double. So we still have 0, 0, but then instead of 1, 1, it's 1, 2, and instead of 2, 2, it's 2, 4, like so. And then we have this one and this one for the same reasons. So that's what our graph looks like. Remember, that's called a vertical stretch. It's like a skinnier version of the graph, which again, if I take this one over here, put it on the parent function, you can see that it is in fact a skinnier version. Okay, and our range didn't change. So our range is still 0 to infinity. It didn't change from the parent function. There's no flipping or this didn't go up or down at all. And there you go. That's how you do those things.